In this video, we're going to look at composite functions. And if you recall, this is what we looked at in the previous video, except for in the previous video, we were focused on the inverse properties, where if you had something as the sine of the arcsine, or the inverse sine of a number like, let's say, 0.12, then as long as this value is within the domain or range, we said then the answer is simply going to be 0.12 because the function and its inverse, they basically undo each other. And if you can always think back to pre-calc 1, the notation we used for composite functions was f of g of x, or we could look at it in the other order, such as g of f of x. Okay? And that's what we're looking at here, except for with this video, the examples we're going to look at, they're not going to be the sine of the arcsine. These are actually going to be different trig functions. So we want to start out with looking at the tangent of the arc cosine of 2/3. Now we're actually going to form a right triangle to do this, and this is where, for this example, we're going to need to look at which quadrant are we going to be located in. So here we need to draw the appropriate triangle, and we're going to recall arc cosine of 2/3. Well, if we're thinking about the cosine, then we know that cosine is really thinking of this as our x over r. So this is representing x over r. Okay, so the arc cosine of this 2/3, remember, the 2/3 is the x and the over r, and we're looking for the angle. So another way to think of this is we can think of this here, this whole thing, once we find the arc cosine of 2/3, is going to be our angle. So we can think of this as the arc cosine of 2/3 is going to be equal to our angle theta. And once we find that, and we're actually not going to find the angle of theta, but we're going to find our right triangle for the angle, and then we can determine what the tangent of that angle is using the right triangle. So another way to think of this, the arc cosine of 2/3 is equal to theta, then we could rewrite this, and that means the cosine of theta is going to be equal to 2/3. So once again here, we're still looking at what is the x over r. So our x is 2 and r is equal to 3. Now, we know if x is a positive 2, we know that we're going to the right, so that means our triangle has to be over here to the right. Now, is the triangle going to go up in the first quadrant, or is it going to go down? Well, this is where we have to think about our arc cosine. Well, we have the arc cosine here, and if you recall, what is the range of our arc cosine? Well, we said it had to be somewhere from 0 to pi. So that means it has to be in the first or second quadrant. Well, because our x value is positive, that means our triangle has to be in the first quadrant. So here's our angle. We know that it's x over r, so therefore we have 2 here, 3 up here. And now we have to find the missing side. So before I go any further, let me go back and review. What we've done here is we've basically taken, using this arc cosine of 2/3, we use that to draw and label our right triangle in the first quadrant. Once you do that, we're simply going to finish the right triangle just like we have in the past. We need to find the remaining side, so we're going to use the Pythagorean theorem, which would tell us that we would have 2 squared plus y squared equals 3 squared. And then we would end up with 4 plus y squared equals 9. So y squared is equal to 5. And if we take the square root, we know that's going to be the square root of 5. And because this is our y value going up into the first quadrant, it must be a positive square root of 5. So now that we have the right triangle, we go up here and we're looking for the tangent. So we're taking the tangent of our angle theta, because remember when we take the arc cosine of 2/3, that's the angle. So the tangent of our angle theta, we just simply go to the triangle. Well, tangent is y over x, so that would simply be the square root of 5 over 2. All right, let's look at another example. This one, we're going to take the cosecant of the arctangent of a negative 5 over 12. Okay, so once again, we want to figure out where are we going to draw our right triangle. And we're going to use the arctangent here to find that. So if again, all of this here is representing our angle, because when you take the inverse tangent or the arctangent of a number, you're finding the angle. And the tangent we know is going to be y over x. Okay, and once again, if it's helpful to rewrite this, you can always write this like I did before. You can think of this as the tangent of theta is equal to a negative 5 over 12. Now at this point, the question becomes, we have this negative 5/12. Where does the negative go? Does it go with the 5 or does it go with the 12? Because if we're looking at this negative sign, it's y over x. So we need to figure out, is the y value going to be negative or is the x value going to be negative? And once again, this is where we have to think about our arctangent. Well, the arctangent, remember, we had to restrict our domain. So when we're thinking of the arctangent, which quadrants could the arctangent be? Well, if you remember, the range is negative pi over 2 up to a positive pi over 2. So that means our triangle must be in the first or fourth quadrant. Well, in order for that to happen, that means that our negative 5 over 12, the negative 5, if that goes with the y value, okay, then that means that we're going to go down. So therefore we have a positive 12, because if the negative went with the 12, that means we would have to be in the second or third. So therefore we have to have a positive 12 and a negative 5. Okay, so once again, hopefully you see this. We're using this piece of information here in the brackets to simply locate and label our right triangle. And once we have the right triangle, we can solve for the missing side using the Pythagorean theorem again. So here we need to find the hypotenuse or the radius. So we could take 12 squared plus a negative 5 squared equals r squared. So 12 squared is 144. And make sure when you square the negative 5, you also square the negative, so that's going to be a positive 25. And 144 plus 25 is going to equal to 169. And if we take the square root, we end up with the square root of 169, which is 13. And we know this is the radius, so it's always positive, so we have a positive 13. Now, at this point, we can find any trig function. In this one now, we want to find the cosecant. And realize at this point we have every side of the triangle, so we could actually find any trig function that we needed. So if we want to find the cosecant of our angle, then the cosecant is the reciprocal of our sine function. So that means our sine function, which is going to be y over r. So that means here this is going to be r over y. So that would be 13 over negative 5. And you could write this as 13 over negative 5 like this. And remember, the negative sign can go really in any place, because if you have a fraction, it's still going to be negative. And even though we know the negative technically goes with the 5 because it's representing the y value, but the 13/5 has to be negative. And I tend to put it always with the numerator. So either way, this is a negative 13 over 5. So once again, to review with both of these examples, you're going to always use here kind of what's in the brackets, this arctangent, or in the previous example, the arc cosine up here. We want to use this to locate and draw the right triangle, use the Pythagorean theorem to find the other missing side, and then you can find the other trig function that you're trying to locate.